Hello, welcome to Unit 7, Lesson 6 on transformations. I'm Professor Blackman. So in this lesson, we're going to be talking about transformations. So here on this slide, I have a lot of notes about the parent functions. So here we have the parent functions. We have here is linear. This is quadratic. We have square root. We have the cubic. We have cube root, we have reciprocal, and absolute value. These are all the different parent functions. Now over here, I have the transformation function that a lot of people will use. And so A, as you see, if A is negative, it's reflected over the x-axis. If A is between 0 and 1, it's a vertical shrink or vertical compression. If A is greater than 1, it's a vertical stretch. And K at the end, if it's positive, we shift up K units. If K is negative, we shift down K units. And then H in the middle, inside the function, if it is positive, we go left. And if it is negative, we go right. I use these over IHOD. If it's on the outside of the function, it affects the vertical, does exactly what you think, and changes the range. And then IHOD is if it's inside the function, it affects the horizontal, does the opposite of what you think, and changes the domain. So these are some notes that I think are very useful. I'd recommend writing them down. Let's look at some examples. All right, so here you can see that we have a h of x, which is the +4 is outside of the function. So that would be like the k in a transformation. So this transformation would be up 4 units. So for a quick sketch, the parent function for a rational looks like this. And when we look at the transformation, instead of having like a middle right there, we'd be up 1, 2, 3, 4. And so this one would look more like this as a transformation, as a rough sketch. All right, let's go to the next one. So we have a 1/2 in the front. So that would be a vertical shrink of 1/2. Shrink of 1/2. And a -2 on the outside affects the vertical. So this would be down 2. So parent function for absolute value looks like this. And if we want to quickly build a table, it would be -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. Now when we are talking about a vertical compression or vertical shrink, so as we apply the 1/2, so this 0.2, half of that would be 1, but then we're also going down 2, so this would be at -1. So it's going up at a slower rate and at the same time down 2. So down 1, 2. And so instead of going here, we would be, instead of being at 1, 1, we're going to go 1 right and half up because it's vertical shrinking. So that one's going to look a lot flatter because it's going up at a slower rate. All right, let's look at some more examples. Okay, so this is a quadratic, and we have a +4 on the inside. And so remember, on the inside, it does the opposite of what you think. So you would think it would be going right 4, but this is actually going to be going left 4 units. So quick sketch of the parent function looks like this. And when we apply the transformation of moving left 4, 1, 2, 3, 4, we now have it looking like that as a rough sketch. All right. Next one, we have a plus 3 inside the function. So that's going to be left 3. And we have a plus 2 on the outside, which would be up 2. So we've already graphed rational ones. So a quick sketch looks like this. And so you have the center at the origin. But now we move that center left 1, 2, 3, and we move it up 2. So now our center is more there. So it looks like that as a rough sketch. All right, let's look at some more. So now we have a cube root function. And we're taking it minus 2 on the outside, so that would be down 2. So a quick sketch of a cube root function looks like that. So as we shift it down 2, it's going to look more like that. Our next one has a lot of changes. The minus on the outside is a reflection over the x-axis. Reflect over x-axis. Some will say flip as well. The minus 3 on the inside makes it go right 3 units. And the plus 5 on the outside goes up 5. So as a quadratic, quick rough sketch looks like that. And now our right 3, 1, 2, 3, and our up 5, 1, 2, 3, 4, 5, is shifting our vertex from there to here. And then as a reflection, looks roughly like that. And so we have a reflection, a right 3, and up 5 shift. All right, let's look at some our final slides. All right, so now we're going to create the equation based on what's given. So knowing that it's y equals x squared, it's going to move upside down. So that's a negative a. And it's going to go right 8 units. So right 8 is on the inside because the inside affects the, so that's a minus, 8 on the inside. Okay, so this is going to look like f of x equals negative on the inside x minus 8, and then make it a squared because this is a quadratic. All right, next one is left 7. So left 7, that's on the inside, so that's going to be plus 7. And then up 2 is on the outside, plus 2. So when we go to graph our absolute value, we have the x plus 7 on the inside and the plus 2 on the outside. So this is left 7 and up 2. All right, we have another one with quadratic, left 6 and down 3. Left 6 would be plus 6 on the inside, and down 3 would be minus 3 on the outside. So that would be y equals, on the inside, x plus 6. Don't forget to put your squared there because it is a quadratic, and then your minus 3 on the outside. We have absolute value of x again, but this one is shifted down. So down affects the vertical, so that's on the outside, so minus 5. So this would be f of x equals absolute value of x, and then on the outside, minus 5. That's all I have for you today. Happy study.